Hello, class. So today we are going to look at how to do some data analysis for your data for your project. So I went ahead and I made some data measurements for the effect that mass has on the period of a oscillator. In this case, I used a spring. And you're obviously going to be doing different things, but the principles will apply the same. There's going to be some things I'm going to be able to do on here that you may not be able to do for yours. It just depends on your experiment. What I encourage you to do is do as many of these as possible, and I will point out the ones that you absolutely have to do if you want to have any sort of good analysis and good conversation about this. So the first thing you need to do is obviously record all your data. I suggest doing it in Excel. This is so much easier in Excel than it is doing by hand. You can do all these things by hand, but they are much more complicated to do. So I suggest doing it in Excel or some other spreadsheet program. So the first thing I do is I put in all of my independent variables. That was my mass. So here's my independent variables I changed. You'll notice I went from 5 grams up to 50, or sorry, from 50 grams up to 500 grams, so 0.05 to 0.5 kilograms. And you would want to label yours. I just haven't done that yet. These are my trials. These are the periods that I have. For each of those, I did 5 trials. You should do as many trials as possible, just like you should do as many independent variables as possible. Okay, some of you are doing 2 different trials. You're doing like 3 trials of one independent variable, or sorry, 3 different independent variables at a set number of trials, and then 3 different independent variables at a different set of trials. That's also fine. Just however you're doing it, put it in here. Also, any other numbers you're going to need, put in there as well, because you may need to reference them. The first thing that all of you should do is find the average of your trials, and that's very easy to do in Excel. Hit equals, and then write average, all caps, put a parentheses, and now you're going to put the range of the numbers you're going to do. So I'm starting here with my 5 kilogram, or sorry, my 0.05 kilogram mass. I'm starting at trial 1, dragging all the way through trial 5. Hit end parentheses, hit enter. Bam, there it is. That's the average for you. You don't have to do it on your calculator. You don't have to type it in. It does it all for you. Now, I want to do the rest of these. Click on my average that I just did. Find that little box in the corner. It'll turn your cursor to a plus sign. Click it, drag it all the way down to the rest of your data table, and bam, there you have it. There is my average for all of my masses there. Okay, and then once I have the average, and that's my average period and my mass, I'm going to go ahead and copy this one down here to lower here in my screen. You'll see why a little bit later, but I'm going to do that for right now. Okay, and then I'm going to do the same thing with the average, but here's the problem. See, since these are calculations, you can't just copy them down. Otherwise, it'll copy the equation and it won't be able to do that here. So I need to just type those in. So I'm going to put period, and I'm going to type in these numbers. 0.422, 0.594, but I should type the right thing. 0.78, 0.88, 0.988, 1.076, 1.172, 1.276, 1.344, and 1.412. Okay, so now I have all those numbers there. So the second thing that's really helpful that you are probably not familiar with is something called standard deviations. Standard deviation is a way to figure out how far apart are your trials from each other. It's a really easy way to show precision. How close were you to your numbers when you did them every time? And it's super easy to do in Excel. Hit equals, type STDEV, again, all caps, start parentheses, and just like you did on average, click at the first trial, drag to the last trial, end parentheses, and hit enter. And there it is. That's your standard deviation. And you're saying to yourself, well, what is this number actually telling me? Here's what it's telling you. It's telling you how far apart are your numbers. And again, the unit for standard deviations is the same unit for what your average is. So it's 0.03 seconds difference on average from these trials. So the largest is 0.47, my smallest is 0.39. That tells me that the largest gap is 0.08 seconds in my period. Well, if I average that across all of them, the average amount that I'm off is there. Now, this is a helpful average to have. So I'm going to go down and put the average here to figure out what is my average standard deviation. How much does that standard deviation change by? And I'm going to do that just like I did before. Average range. Here's my range. Okay. All right. So that's the first thing you should do, or second thing, I guess I should say. The first thing you need to do is find the average. The second thing you need to do is find the standard deviation. The third thing you should do is make a graph to look at. So if you're not sure what to graph, here's what you should try to graph. Graph your independent variable versus your average dependent variable. So the average of your trials for each of those independent variables. So I'm going to graph mass versus period here. Now, this graph is going to look a little off, and the reason it's going to look a little off is because the graph is actually period squared versus mass. But for our purposes, I'm just going to graph it the way it is. Now, when you do the graph, you want to have two columns. One for your math. You don't want to graph all this. Don't graph all, oh, it's just going to be gross. Don't graph all that. What you want to graph is your x variable first. That's your independent variable. And your y variable second. In this case, it's my period, the dependent variable. All you have to do to graph it, grab it and highlight it. Again, this is why you'd like to use Excel, because this is so much easier than graphing it by hand. Can you graph it by hand? You absolutely can graph it by hand, but I would suggest not if you can avoid it. Okay, once you've done that and you've highlighted that, we're going to go up here, go to Insert, go over here to where the data charts are, and select Scatter. Okay, and here's my scatter graph that comes up. Now here's the thing. This is not a very helpful chart, so we're going to go ahead and make some changes to it here. If you click on it, click on this plus, we're going to add a few things. We're going to add axis titles. Okay, you can do data labels if you want. You can do charts if you want. You can do grid lines are helpful. The legend if you need it, and you definitely want a trend line. Okay, there's options on the trend line here, linear, exponential, all those kind of things. Just linear is fine. Click on the trend line, it'll do a linear trend line. Now, when I'm looking at my data table before I do anything else, I see this number's really funky. And so I'm going to go back and look, and it's 1.644. Oh, it was actually 1.344. So I'm just going to change that 1.344. And notice, oh snap, it jumped right back in where it was supposed to. So now that I've got the basics set up here, I'm going to right-click my chart. I'm going to change it to Move Chart. And I'll move it to its own new sheet. And I'm going to call this period versus mass. Okay. And here we go. So change my title to period versus mass. Okay. My axis title over here, this is period. Now again, you'll notice that my chart doesn't look like a linear chart. That's because it's actually supposed to be period squared, but it's not important for my purposes here. So this is my dependent variable. This was period. Make sure you include the unit, seconds. Okay, down here, this was my dependent variable, sorry, my independent variable, and that was mass, and that was measured in kilograms. So here's the importance of doing a graph. Now I have something to reference when I'm doing my analysis and I'm talking about what relationship I saw. Oh, look, according to my graph, as I increased my mass, I increased the period. And I can further say that it seems to be accurate because it follows a fairly nice trend line. And I can even further say that, well, at the beginning, it seems to do something different. And so I can talk about all those things just from a graph. If you don't have the graph, you're going to be in trouble a little bit with that because, let's see, let's go back. Yeah. If you don't have a graph, how do you talk about this? Well, okay, my numbers get bigger, but that's easier said than done. How do they get bigger? Are they consistent? Are they inconsistent? All those sort of things. So these are the things that all of you should do. You should all do those. You can do them on all of your projects. If you can't do them, then you need to redo your data because it's not scientific enough. These are all things you can do regardless of what your experiment is. You can find the average, you can find the standard deviations of those, and then you can plot a graph of your independent versus dependent variable.